Let me make sure this camera is following me, and then we are smooth sailing. Okay, we're working. Hello, everybody. Happy New Year. Welcome to the first IGDA TC Game Dev meetup of 2026. So excited to see y'all. It has been a minute. I'm just getting my presenter view up here. For those of you who have been here before, welcome back. For those of you who it's your first time, welcome in. Any first timers here? Amazing. Welcome. Thank you for coming out here. If you are interested in our safe event policy, you can find it at igdatc.org/policies. Fun facts about IGDATC, for those of you who don't know, we are all volunteer. This is a community-run organization led by a volunteer board. You can see our board members here, some of whom are in the room right now, watching, lurking in the shadows. Some of whom are also up for re-election, which we will get into in a minute. But if you don't want to deal with all that rigmarole, you could be a volunteer and do basically the same thing. So if you are interested in providing any services to the community, if you have an idea for an event, if you're really good at social media, or have some other skill that you are interested in contributing towards the community's programming, let someone know, and they will point you towards someone who can help you make that happen. Or reach out on Discord. We have so many regular events, 6 recurring events every month. First Wednesday of every month is Jam Night, a social co-working night for you to bring whatever you've been fiddling with lately and work on it while chatting with other designers. Our Game Dev meetup is the second Wednesday of every month here at 2DHQ. Community presentations and networking. Twin Cities playtest at Noble Robot every third Wednesday. Jam Night is also at Noble Robot, forgot that. Twin Cities playtest is a night to play or show off your own in-development games. Send Mark LaCroix a build on Discord ASAP. So if you're thinking of getting involved in this playtest as soon as possible, send Mark a DM, send him a build. We'll make it happen. But you can also bring something in last minute, and we'll try to figure out a spot for you to show it.
What if my game is terrible?
Bring it.
So much is the better.
Exactly. The worse the game, the more helpful the eyes and the hands and the feedback. Exactly. Games that are not show-offable looking are the ones that need eyes most. Now I'm starting to talk. Let's keep it going. Fourth Wednesday of every month is our MNVR and HCI meetup. It is a VR, AR, HCI specific meetup with presentations, demos, and group discussions at REM5 Studios in St. Louis Park. And then every third Saturday is our Women in Games Gathering, a no agenda networking and social event open to anyone who identifies as with the label of woman and is involved or peripheral to game development. And Game.wave every second Thursday, except for this month. It's the third Wednesday this month, which is tomorrow, 6:30 to 8:30 at Hennepin Technical College, Audio Production Department, for discussions and deep dives on anything related to audio. If you want to add another event to this list and make me talk more at these meetings, let us know. It would be so fun. You can reach out to anyone on the board or send a message just in any of our channels, and I'm sure a conversation will grow from there. You can find more details about each of these events at the events info channel on our Discord. Fun facts about the things happening. There is a lot happening in January, everybody. Global Game Jam 2026 is coming up. We've got some images from previous years. It is going to be January 30th through February 1st. This is going to be a stretch where we are going to be hosting a site for Global Game Jam. If you are interested in participating, we have options to participate remote, in person, or hybrid if you have some people that can't make it in person. You can find all the details and more at igdatc.org/GGJ. Our in-person site will be here, 2DHQ in Minneapolis. And we have a Discord server for all of our jams that we host as IGDATC. You can find through this link as well. I will say, if you are thinking of signing up for Global Game Jam, which you should, because it's so fun, you should go through that link and set up an account and register on the Global Game Jam website ASAP, because that is a required part of getting your game uploaded to their website for this jam. Other thing, leaving this up, this was from our last meeting as well. We have revitalized our Steam group. So feel free to scan this QR code or just find us community group IGDATC. Thank you, Trent, for revitalizing it. And thank you. Yeah, yeah. This is kind of my reminder as well. Like, when you scan it, you have to click a weird button.
People use Steam. They know.
Yeah, yeah. IGDATC exists on Steam as a community. I'm sure they can find it even just through that much information. But thank you, Trent, for helping set this up. And thank you, Bill, someone from 15 years ago who just had the keys to this group originally, for handing it over so generously. We're going to keep the thanks rolling. Thank you to our event sponsors. These 4 locations are places that sponsor our events. They are amazing businesses who provide amazing services, and you should provide them with support if your interests align. Check them out. Co-working, events, VR, education. They got it all. And we can also thank Nice Games Alliance. This is the nonprofit organization that helps fund and sponsor IGDATC events. It's the reason we've got this fancy doohickey recording pristine audio and video for this event to be documented long term. It is also how we've put on events like our holiday party. It is how we pay volunteer hosts for events. So if you have found any value in this community and have the means to do so, any donation is incredibly impactful, and it is tax deductible. You get a receipt. Super easy, super cool. All right, community plugs. Rob, at what point did you want to do the game.wave? Okay, cool. Community plugs. This is still going on. UMN IP Law Clinic. They have UMN legal students who are putting on clinics for consultation if you are interested in any matters of IP law. If you're looking at incorporating that Game Jam game that you really, really liked, they still, I believe, are taking appointments. I'm not certain. Don't take my word on that. Available through available January through April of this year. Email lawclinic@umn.edu or call them at their phone number or visit them online. All right. And then Ruben, if you would like to come on up. And then it's this microphone right here, and I'm going to shift off with you so that hopefully the camera continues to track you.
Okay. Hi, camera. Oh, no.
In behind you. Okay, you can go ahead. I'm going to fix the camera while you're talking.
Okay. Hello, everybody. I just want to speak a little bit off the cuff about this. I'm really proud to be in Minnesota this month. I think it's been a really great place for me. I'm actually a legal immigrant, so all of you who are up there doing activist work, calling your representatives and, you know, standing outside in the cold, I really, really appreciate what you're doing. Thank you very much. And it kind of flows into this. You know, this is all about Minnesota. The Minnesota mixtape. My friend Zach and I came up with this idea a couple months ago. We weren't really sure how we would go about it, so we didn't really announce it during the party. But we kind of put our thoughts together and kind of solidified something. What we want to do is help people get their games on Steam. Whether you have a Steam account or not, that's not really a huge requirement. We just want to make sure your name is out there and that you've released the game, that you've gone through the process, and know what it's like to be on Steam. I mean, I would encourage you to make an account if you want to be on this, but you don't have to. Anyways, we want to make a collection about games that remind you of Minnesota. So things like ice fishing. Zach's doing something about what is it? Snowboarding? No.
I'm gonna do a snowmobiling game.
Snowmobiling. Yeah, there's a rum running game where you drive on a frozen lake. And a friend of ours is doing like a disc golf game. So anything that you might want to do about Minnesota that reminds you of home, that you do in the summer, winter, fall, whenever, this is the kind of thing that you should be in. Who can join? We're pretty much open to anybody. All we're looking for is a short 5-minute experience of something arcadey that doesn't take a long time. If you want to make it a little longer, it's up to you, but do want to kind of like wrap up the final list of people in February, and we want to release sometime this year. Um, we don't really have any solid dates yet, but as soon as we finalize the list of people who are going to be on it, we'll probably start talking about dates and potential game jam dates or whatever to get to get everything together. There's one more slide.
Yes.
Thank you. Okay. How do you join? I'll post a Excel spreadsheet. Otherwise, you can just DM me if you want. But I'm gonna post an Excel spreadsheet later tonight where you can just hop in, put your Discord handle in, game idea, HIL link, social media link, whatever you want, and you'll be part of it. That's all you gotta do. And then I'll DM you once the thing closes, and then we'll confirm everybody's interest and all that. As I said, the time frame still a little bit up in the air, but we definitely want to wrap up the final list of people by the end of February. And if you want to submit this game jam game coming up, feel free to. The theme is pretty loose. I mean, just the virtue of you being a Minnesotan kind of counts. So if you really want to put your game jam thing in there, more than happy to accommodate that. And that's all I have to say for it.
Something to keep in mind for those of you who are considering participating in Global Game Jam and are maybe interested in using any of our local diversifiers, which we do every year. We haven't solidified for this year yet, but often include something related to theming around the local state's motifs. This is my thing. Every month, Jam a Jam happens, which is a monthly remote asset jam. So shorter scope than a game jam. You're just making one asset that can relate to whatever your creative discipline is. We have a theme that comes out each month. These are some of our winners from this past month. The theme was Good Luck Charm. It is hosted starts every first Friday of the month from 6 p.m. Friday to 6 p.m. Sunday CST. And we have an off-season theme each month. The theme for the off-season is farm. So if you're doing any farm things right now, or you're looking for inspirations to do so, post something in the Jam a Jam Discord, which I am currently blocking, or I will send a link later. You can do whatever assets you would like. This person submitted one that was like a item card that they then printed out for a tabletop game that they were playing. So whatever your discipline is, whether it's 3D, 2D, audio, video, compositing, programming, scripting, gameplay programming, you can do anything that relates to your discipline. And also, okay, go for it. Wake up.
Yeah.
There we go. Awesome. This guy. There we go.
Nice Game Stop. This is the podcast that I do with some pals who you may know. We are on hiatus right now, which means reruns, but it means the best episodes of the year are being run now through the end of February. So check that out. A couple of examples behind my head there that you can kind of see. And that's all I have to say about that. But I came up, even though you usually do this for me, because I also have a thing next
Indeed.
after this.
Oh, yes, indeed. Should I switch over to...
Nope. We're still in
Okay.
Here we go. So, I am often told I need to brag more about stuff that I do, so I thought I would actually come up here just solely to brag. The game I released in 2025, Blippo Plus, nominated for Indie Game Oscars, aka the Independent Games Festival, in 4 categories, including the grand prize. It's very exciting. We got a honorable mention in narrative, which I say it's the thing I had the least involvement in. It's probably the best thing about the game. I love the writing in it so much. That's going to be announced at GDC, and so I'll be up there. Like I don't know to tie, so probably just looking like this.
Yeah.
But I'm pretty excited about it.
That's incredible.
Yeah.
Yes, congratulations.
Thank you, everybody. And then I'll be back for the election stuff, but I think you have something to talk about in the meantime, right?
Yes, indeed. I think we are there. Rob's got in.
Didn't you want to? Okay.
Slides in here.
Yes. Rob's gonna take over here real quick.
So, with the camera, you can just, you don't need to turn it off and on. You shouldn't have to. You should
Perfect.
just be able to hijack it and point it at somebody and should be able to pick it up. I think.
Okay.
We'll see.
Yeah. Fingers crossed.
Yeah.
There we go.
Game
This is
Wave.
a Game.Wave takeover.
It's a takeover. Because all you won't come. I'm just kidding. Yeah, yeah, that's right. So, game.wave. It's a thing. I don't know how to do this. Do I just do this? Ha! What is game.wave? So, game.wave is game audio discussions and deep dives. I'm going to read this word for word, just so you know. Game.wave is an inclusive place for audio-focused discussions and sourcing feedback on all your lovely sounds for game-related designs. This event is open to experienced sound designers as well as newcomers and dabblers seeking guidance. It's open to anybody, so you can come if you just want to listen, whatever. So that's what it is. It's at Hennepin Tech. We talked about it already. Hosted by me, Robert Frost III. You can call me Rob. What? Which branch? Yeah, right there. Eden Prairie, Minnesota, 55347. It's on room H183. And it's usually 6:30 to 8, or it's 6:30. We usually end around 8. And then we go to champs. Where's my champs? Champs. Where's my champs, people? With champs with 2 P's. It's real weird. I just so everybody knows, this is Lion Cloud Drive. Drive this way. I've gotten people confused, so I want to make sure that. Yeah. So you take a right onto College Drive or College, whatever that is, and then you can either go this way, that way, but go straight. And straight will get you. You'll kind of go do this weird loop. You'll be like, "Why am I doing this? I don't understand." But then you'll arrive here eventually. Park there. And then H1. Boom. H1. It's right there. That's that door. It says H1. And it's open. So don't tell me it's not open, because it's open. And those flagpoles sound really cool, just so you know. Yeah, I'll probably help you out. Yeah.
But it's
So-
like the first door on the right to get in.
Yeah, and it's right there. And then the bathrooms, straight through. Yeah, it's a little confusing. So I'm sorry it's not perfect, all right? It's the best I can do for free. Okay, so I'm just gonna kind of talk about like what we kind of do in our meetings. A lot like these meetings, you know, obviously we talk about game audio stuff, but we do more. But we do more discussion-based things, because that's my forte, is more discussion. I've tried to do presentations and stuff, and they're just so stressful. So, but we do allow member presentations. So if you're interested in something, or like an expert in something, or even just want to, you know, make a presentation and talk, totally cool. You can do that. Just come to me and ask me, no problem. Scott did a great one. He was the first member presentation, and I didn't record it on accident.
I've been meaning to re-record.
And he's going to re-record it, he says. It was really awesome. It was about audio, math, and stuff for game development. So, so playback feedback is the first segment that we usually do. And this is important. I think feedback is a really, really important, a crucial part of any creative process, especially commercial. Because, you know, you can make stuff in the void if you know, just want to make something. But if you want people to like it, or at least take it in and understand it, have a hot take about it, you need to have it sort of understood, I guess. So this is kind of a way for us to kind of talk about your songs. So I'll have you, you know, come in, and you can bring your WAV files, your FLAC files, your OGG files, whatever plays on a computer. And then I can play it over the stream, because I do stream it, and then we'll talk about it. So yeah, it's pretty straightforward, but it's really important, I think, because feedback is essential. So that's what we spend probably half hour or so talking about music, and you can really talk about anything. Like, even if it's not even, you're just thinking about something, an idea, you're still in cultivating it. So yeah, so share things. So button doesn't work. That's okay. Buttons sometimes don't work.
No, it should-
So the next thing we really, the other thing we do when we don't have a member presentation is we do sound reveal. And sound reveal is a newish thing that I kind of came up with, where I strip the sound from a video, a clip, and then we kind of discuss, what it needs. And I have a little bit of a framework for it. So let's try to do one now, actually. So first of all, the first things that we kind of need to discuss are some foods for thought when we're doing this. So this is kind of my process whenever I'm working with any developer, is just like kind of asking these basic questions. So like, what's the vibe of the game? What's the genre? Sometimes this stuff can really help us make the nitty gritty details, or even, there's some games that have particular things that are expected in that genre. So knowing those things, we can just automatically, start there. And what's the game design? What is it about? Like, what are we doing? What's the reason I'm playing this? What's the goal? Because we're not making, film here. We're not seeing something and then making it. Well, we are, but what I'm trying to say is that, like, there's game design behind it all. That's the engine. We are just the sound of that engine. And then how should the player feel? It's a extremely important thing, especially this word, feel. We're the feels on like we handle the feels along with art and story. It's still a lot of things, but sound really does it. And then, like, what's the time period? What's the setting? What's the, like, a door opening could sound completely different in sci-fi era than in medieval times or whatever. So that stuff's important. So, and then the next thing, there's another one before I do this. And then a little bit of another framework is, these are some typical categories that things are kind of bundled in. NPCs, meaning really anything that's not a player that interacts or speaks, or enemies, or anything like that. Player sounds, anything the player does, jumping, running, spitting, could happen. And then sound effects that are part of the game. Sound effects like door closes and just like everything else basically that's not specifically based on a player or an interactable player. UI, UX, non-diegetic stuff that informs the player, feedback, but like stuff that's not necessarily going to be heard by the people in the game. It's more for us. And then ambience, massively important for story and world building, stuff like that. So these are just some of the things that I want you to think about when we are looking at this clip. So so I'm gonna need to like use this a lot. Yeah.
This is just if you drag anything over.
Okay. So I've got a clip here from a really nobody knows this game. It's see you later. See you tomorrow. How do I get over there? Nobody's ever heard of this game. I know it. It's very rare. It's a very rare find. Yeah, so we're gonna watch this clip from beginning to end. It's like a minute long. I don't know where my
So this side will go up onto
okay,
that side.
got it. Okay, so oh boy, this is inverted. Holy crap. I need to go to the beginning. No one's ever heard of this game. It's called Elden Ring. Never heard of that one, right? So right now, what I want you to start thinking about is what is happening in this game. Like, what is really happening? Not just like you know, the visuals. It's going through menus. Going through menus. It's getting up. Yep, it's going through the fireplace. We're loading screen. It's getting up. So this is so we're mostly just taking in what we're seeing. We're not really saying anything. Yeah. Okay. So the casting of the magic. So what would we say? What would we say like the environment sounds like? Stones and wood. You were high up, yeah. Yeah. So yeah. Yeah. That's definitely things that's to consider. So from what I saw, it looked like a battle had either taken place or was taking place. So that could actually tell us a lot about what sound could and should be there too. If a battle is still taking place, only not up there, we could hear stuff out in the backgrounds, you know, whatever to kind of bring us to the moment of like, why are we here? What are we doing here? And what's happening around us? It could be important to the story. It could be important. Um, but really, the we were what I'm really trying to get at here is that the character is attacking enemies and like looting things, and so we need to be careful, or you know, closeness to these different objects. I'm sorry, I'm really distracted. I got distracted and thrown off by things over here, so now I'm all distracted. So where was I? So can I actually look at this again? Because that would be really cool. Yeah. So let's just play it. So what are some of the what's the terrain? What are we seeing? Cobblestone looks like grass. I did see a puddle. Yeah, there was exploding. There's an enemy there. There's some UI elements. Does any of those need sound? Yeah, but it depends on the game too. It depends on the style. Like we don't necessarily, you know, need it for maybe this because we want it to be focused. We want the sound to be focused so that it's all about the player. It's all about that player's experience, especially in an RPG, especially for something like this. Um, so yeah, like selecting menus. I put that in there just because I wanted to make sure we talked about UI. Get up. Yep. Yeah. Okay, so yep. It's definitely dark. It's not like happy, right? That bird has what like chains on it, so like some crazy chain action. I don't know. Swords, casting, death.
Some sort of item that's coming out.
Yeah, it looks like it's shooting towards you, which could be an element of UI or it actually could be part of the world. It's not really that clear. So, and then
Obviously, there must have been some of the enemies that was
s-
waiting for the player to so quickly, right?
yeah, explosion. There was an explosion in there, but not like any explosion. It was like a barrel explosion, right? So it was like probably not the strongest explosion in the world, but it's also not, just like a quick burst. Yeah. 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 So this is kind of the stuff. This is what we kind of do. This is we dissect things. We talk about the way they make people feel and the way that and even like how we might actually design these sounds or and stuff like that. So that's all the time that I have, my friends, and 17 minutes. Good job. Not bad at all, even with distractions. Tomorrow at 6:30, you can find me with my computer and whatnots at Hennepin Tech H1, door to the right.
All right.
Bathroom in the back. No swear waves.
No swear waves. And are we still on dot wave or is it dot lab?
Dot wave.
Dot wave.
Da wave.
Dot wave.
DAWAV.
I actually thought about calling it Game Wave, but then I was like, no, I'm not. I'm sticking to my guns here. The name is Game Dot Wave.
Da wave. Alrighty. Do. I'm just pulling this down. There we go. Yep. Alrighty. We've got another stage of things to do before we get going. What's up? Okay, this is my computer. Are you in the...
No, I was getting into it.
Oh, okay, perfect. Cool. Whichever works. Damn, and then... Yeah. Okay, and then you should be able to just arrow keys. And then the room, that one.
Did we update that?
This is the one that was messed up.
So there should. Right. This is the one that's.
Oh, okay.
That's
Okay.
corrected.
Gotcha. It just doesn't have the
So
display.
what we need to.
Or, I think it's this one.
6. 6. Emphasis on 6.
Yes.
So we didn't do it for both scenes. That was the problem.
Okay, perfect.
And we actually went a little higher here. That should be okay for Q&A, but I'll tweak if we need it.
Perfect. And I'm just gonna fix the camera. There we go. There we go. Okay. Arrow keys should switch.
Okay. Should go. Sorry, I can't see my own slides this way.
I can set up a presenter view real quick.
I'll just.
Okay.
Okay. Yeah. Okay. Okay. I'll manage. My eyes are still okay. Okay. Okay, everybody, listen the hell up. This is the boring part of the meeting. I'm sorry to say. Let's hear it for the boring. This is logistical business. Okay, so this is the third year we've run this version of the elections process, I think. Who is familiar with how we do this? Okay, so kind of most of you, some of you, fewer than should. But this will be new to some of you. I'm going to try to barrel through this as quick as I can because we have a pretty meaty presentation I don't want to steal from. But basically, the TLDR is that the Nice Games Alliance Permanent Programming Committee, which you would also know as the IGGHC Board, is what programs all our events. You've heard Sam talk about it at the beginning of the event, but that group is elected by you. Every year, the community holds elections to fill half of the seats. And there's a current maximum of 7, so it's 3 or 4 open seats. People have to run for re-election if they're on the board, and that's what's going to be happening starting today. So all the rules for this, how it works, all the way down to when we have to roll a die, is at our page on our website, the governance page. So you can check that out at your leisure. I'm going to walk through it at a high level, and then there's going to be something that's going to start tonight, which is nominations. Don't panic. You've got a whole month to process that. Then a month after that, or actually 2 months after that, we're going to actually do the election. So it's a casual, slow thing, but I got to feed you the knowledge now. So it's a 3-meeting process. This is the first meeting where I just explain it and nominations open. Next meeting, the nominations will close, and then voting will begin. And then normally we do the election, we close the election at the next meeting. So if you forget to vote in that month, you've got during the meeting to get your vote in. But because GDC is happening the week of the Gamedev meeting in March, we're pushing the election all the way to April. So you actually have a 2-month window to actually vote for the candidates. Plenty of time, no excuses. We will remind you as we go. But again, that's what happens in these meetings. The basic summary is committee members, board members, they have terms that last 2 years. Roughly 24 months, depending on when the elections fall. No term limits, so you can stay on the board until you make everybody angry. And we hold elections every year, as I said up top. You can run for re-election. New candidates must be nominated by another community member. You can't say, I want to do it. You have to have a friend who tells everyone that you want to do it. That's actually a very easy requirement, but just a little bit of friction that we add to the process. Everyone who is a candidate provides a statement about what they'd want to do, and it doesn't have to be, high-level politicking. You can just say, like, I want to talk more about X in our community. That's enough. It's up to the community to decide what it is. If you have a good relationship with people, you can make your statement short and everyone gets your deal. Totally fine. If you're new to the community and you want to really explain what you want out of it, that's great too. No wrong answers. Voters can vote for multiple candidates, and I'll describe that process. Open seats are won by highest vote getters. So basically, it just, as long as there are seats open, we just keep going down until we run out of seats. Ties are determined by die roll, because we don't want people to pick their second favorites. We want, because you get multiple votes, we don't want to make this a stressful process for anybody. So we figure ties, die roll, easy peasy, we're game developers. It's a D20. That's actually outlined in the rules. A candidate must receive 25% of the vote, so if there's a low turnout for the election, you can't just get in on 2 votes if not a lot of people are participating. It's a little bit more friction, but it's pretty simple. Now, why would you even bother being part of this process, especially as complicated as I'm making it sound? If you want to volunteer to help run one of our regular events, if you're part of the committee, you're a little bit more engaged by default. Not a requirement. We have lots of volunteers who run meetings that are not part of the committee. Also, if you are on the committee and then not on the committee later, you can keep running an event. Not a requirement, but it's nice because you're a little closer to the center of action. If you want to help or manage our online presence, again, you can not just help volunteer, but you can help direct it a little bit more if you're on the committee. If you want to change policy, if you're like, we should do things differently, that's a great reason. I think we have the support of the community for how we run things now, but we don't want things to calcify. If you've got new ideas, if you want to kickstart some change, this is your way to do it. If you have a project, something that's different from what we do, but you think would work great in this, and you kind of want to build some support for it, and maybe even unlock some funds from Nice Games Alliance, this is a good way to sort of be part of that process. Again, not the only way to do it. If you have skills that you can effectively employ, so this is like organizational skills. Like a lot of what we do is logistics. Like we're game developers, we're not suited to this professionally. So if you have some skills that can help, some experience, then we'd love to have that on the board. What we're able to do is a combination of what is available on the board, the talents of the people involved. And if you can contribute to that, we'd love to have you. If you want to help bring more people to the community or more resources to the community, also a great place to do it is on the committee. Who can serve on the committee? Anybody. So no qualifications of any kind. If you've never shipped a game, if you've never written a line of code, it's about community, not about what the community does necessarily. Like you don't have to, there's imposter syndrome runs through a lot of indie communities, and we want to make it really clear we could give a shit about your accomplishments, or even how long you've been part of the community. Like if you just showed up last week to your first meeting and you want to make it, it's up to everyone to vote for you. We would love to have you run, and there's no shame in not winning. So we want people engaged. So no excuses if you're interested. We say that you want to commit to attend many of our events. We have some rules about that. But if if you think you can reach those thresholds, they're not very high, you're good. You must reside in the state of Minnesota. If you're about to leave town or you drive in from really far away, the current board can vote a special dispensation, but we're not getting anyone from Virginia running for the board is really all that means. Nominations, so it can be any person, but must be nominated by a community member. A community member is basically anyone who's been to a meeting, anyone who's on the Discord, pretty much anybody. The board can vote on special cases, but we don't keep member rolls. We don't have registration fees. Our membership is fluid. We kind of know it when we see it, and we want to keep it as open as possible, both to people who can vote, who can nominate, and who can run. Trent. We did. We had a newsletter long ago that was when you signed up through Eventbrite, the way we used to do events, you were part of that newsletter. So that was a criteria when we started this process. I wrote the original process in 2021, and back then it was still sort of true. So we have to change these rules, we have to vote on them. So that's still a qualification. So if you don't come to any events, but you're on the newsletter, I guess you can nominate someone.
So what I'm hearing is that we should bring the newsletter.
If someone wants to run on that platform to bring in the newsletter back, like, hey, let's hear it. Let's hear about it. You can't nominate yourself. I mentioned that already. So nominations are submitted in two ways. So online, there's a Google form that is up now, and that's at the governance link. I'll show that again at the end. You can, starting now, you can nominate folks. And then at next month's meeting, when the nominations close at the end of the meeting, you can nominate someone in person if you forgot or you want to make a little speech like, my pal is super cool. Also, that's when we'll be like bugging you to do it. So that's the nomination meeting, but you have until then to nominate folks. You can nominate up to 2 people. You have to nominate at least one, or else why are you filling out this form? And you should include a method of contact for that person so we can get in touch. You'll also be including your Discord or email so we can verify that you're one of that, that loose definition of community member. And you can't nominate yourself, and you can't game the system. You can't have 2 friends nominating each other. We have a rule about that. It's pretty simple. Current members who want to run for re-election don't need to be renominated. They can run if they want to. So that's a we assume that they have the support to do it, so we don't make them go through the rigmarole. And then if you want to share a statement at next month's meeting to talk about why this person you're nominating is cool, you can. You don't have to. If you're nominated and you want to talk a little bit about at that point, it's pretty loosey-goosey. And if you're nominated and you're like, what the hell? Like, you can just say no, it's fine. If someone springs it on you, you're not obligated, obviously. You can certainly also, like I said, you can't nominate yourself, but you can politic. You can be like, hey, will you nominate me? That's how easy it is. It's a very, very small amount of friction. Once we determine the slate, in the time between the nomination meeting and the election meeting, nominated candidates will be asked to provide a statement. So what we've done in the past, and it can be different, but we've done it the same these last 2 times, is we just have a 5-question questionnaire, just saying like, what would you like to do? What's your background in the community? And then you can open-ended questions. So that goes on a spreadsheet that is then publicly available to everybody. We share that on the Discord once everyone's submitted their answers. So that gives everyone a time to get to know you, say if they haven't come to a meeting or they don't know you personally, get a good idea. And then at the election meeting, while voting is still open, we ask everyone to get up and talk a little bit about their candidacy. That's actually not required, but that might be a good reason to build some support near the end. So pretty simple there. The election, all community members, including board members and standing candidates, can cast votes. The way it works is you actually vote for multiple candidates. So you're not going to have to choose between your friends necessarily unless you have a lot of friends. And I don't have a lot of friends. Do any of you have a lot of friends? That doesn't seem to be a problem in this community, right? No, of course it's a problem in this community, but you get to do multiple votes. And that depends on how many candidates are running. So we have a little formula. If a lot of people run and there are a lot of seats, you actually end up getting a lot of votes to cast. So we try to make that sort of frictionless so you don't have to make too many hard decisions as a voter. And the calculation is there, and here's some examples. You can look at this in the document. I think the first time I did this, I went through every one of these, and so boring. We have a minimum voter participation level, so if for some reason at our election meeting, not a lot of people have voted, and not a lot of people voted the thing, and we just don't have enough people based on this formula, we just delay the vote to the next month until we get enough votes, just so that there's some community validation in the choices that are made. Candidates are elected in the order of the greatest number of votes, filling open seats. If there are fewer candidates than seats, so you'd think, well, then everybody will win, right? We still run the election because you need to get 25% support. And that also basically means that there can be fewer candidates elected than open seats if there's only a few people with support. Not likely, but we make it there so it's a pretty light operation. We could, we don't want the people that we accidentally voted in by 2 votes or whatever.
Can I ask a question about
Yeah.
I believe it said that there's a seat open in a given time that this happens.
I think the rules say that there can be up to 5 can be open, but because of the way we do it and the way terms are certainly, we have not had that. But like people can quit in the middle of a term or whatever. But right now it's been going back and forth, 3 and 4.
So how does everyone clear 25% scores?
Because you get multiple votes.
So 100% mean 100% would mean that every person who voted for you. 25% means that all of the people who voted. Oh, it's the percentage of voters who cast any of their votes.
Yes, of all votes. Yeah, not all. Yeah. No, I can see how that's a little bit. Yeah. And these are all details for you not to care about, frankly. But like we like to let everybody know so it's an open process. So if you are dozing off in this meeting, it's important to know that you should nominate someone, you should vote. If you're interested in the details, here they are for you. But we just want to make sure that it's a really open process because we're a bunch of friends and we want to make sure that it's clear how it works. And that can lead to some how does that work exactly? The document's available if you really want to pour through it, of course. Yeah, that was a bit that I did. Yeah. No, my real problem is that I'm not funny, so nobody got it. Here's some more examples of how a ballot runoff would work. It's super fascinating to me as a game designer, but not worth your time wasting. All right, here's the nomination form. So it's at igdatc.org/governance. It's at the top of the page. It's a Google form link. Pretty simple. If you have questions, please ask in the Discord. If you want to talk about it, if you want to say, hey, I'm interested, would someone nominate me? Use the Discord, use the meeting, politic with your friends. Don't worry about it. Don't worry about how many seats are open or who's running for re-election. Everyone's got a chance. And that's pretty much the end of it. Does anybody have any questions? Dale really has a question.
Who could we vote out this term?
Who could you vote out this term?
Yeah, who's up for re-election?
We'll. So as I understand it, some of the board members who are up for re-election are running for re-election. Some are not, but that isn't finalized until the nomination meeting. So I would say don't worry about it. With nominees, whose terms are up? Sam, Trenton, and Deanna terms are up. Yeah. 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 But I mean, truly, you shouldn't worry about that part of it now. If you want to nominate, don't worry about stealing a spot that a friend might have. And all of that will be more detailed at the next meeting when it's time to decide who to vote for. When it's time to decide who to nominate, blue sky. Question.
So if you nominate someone, you can't be nominated, correct?
You can't be nominated by that person. Yeah. Yeah, you can't build like a donut chain, like a web ring of nominations, like a cabal. Yeah, yeah. It's truly like, as a game designer, when I put this process together, it was very much like, how could it be exploited? But like, we're not especially worried about that.
But I've kind of explained it in the opposite direction.
Oh, I see. I see. Okay. Question.
So, what did you say about once you get the candidates, where that information will be? I mean, Discord. Or
Yes. So, one. When you fill in the nomination form, it'll come to the current committee. Then at the nomination meeting, we will announce who has been nominated so far, and then we will also say anybody else. We have until the end of the meeting to nominate someone else. And at the very end of that meeting, we will scurry away, update the list, and then the ballot will be available. And we'll announce that at the end of that meeting as well.
how do you find out?
Oh, at that point, between the nomination meeting and the election meeting, we ask the candidates to submit a questionnaire about what they're interested in. And that's how, and then we share that on the Discord, and Sam makes announcements, and we do reminders through the month, all the way till the election meeting. And then at the election meeting itself is when we do the whole process. Everybody gets up to talk, but of course, not everyone comes to every meeting. So that's why we have a lot of time. We use the Discord to share that information, so you don't feel like you missed your chance to vote because like the weather was bad or something, or because you had something going on. We try to make it as effortless as possible, which is also why it's a little complicated, because it's trying to let everyone have a chance to participate as easy as possible. The complication is on our end for the most part. Okay, anybody else? No, great. Crickets, brilliant. Time for the actual presentation. Sam, come on back up for the transition, and I'll get out of your hair.
All right.
Sort of like had to do this in short order. I gave myself like a week to do the presentation and the article, but I don't know why I opted myself into extra work, but there you go. Okay, moving on. So who am I? I am Scott Lembcke. I am one half of Howling Moon Software. Andy over there is the other half. We started our own company to make games and do game-related stuff like 20 years ago almost now, in 2009. Yeah, so we've done a lot of computer graphics-y stuff. We've written a lot of like games just sort of from scratch. Write OpenGL code and draw graphics. In order to do that, a lot of that, we needed to know how transforms work. And I'm also like that annoying guy that, you know, like a lot of times where we run into problems, I'm like, oh, this problem would be so much easier. It'd be like a line of code to do this if we just use Matrix. And Andy oftentimes.
2 days later.
And Andy often is like, you know, rolling his eyes like, sure, sure. But like, to be fair, there's a problem that like people have been struggling with for like a week. And so like, then like redoing it, and like we actually were able to make progress on it. And delete a bunch of code in the process. Oh, and also, since there's too many Scots in this group, I'd also, you know, I've been called, you know, Great Scott or the Best Scots. I just throwing out the options. Yeah. Ooh, boo. Yeah, and so there's a screenshot of my game Viridian Expanse, which also is sort of kind of written from scratch and uses a lot of transforms in the code.
That's pretty cool.
Yeah, thank you. Yeah, so the basic idea of my presentation here is, let's see if we can get this on the screen. Everyone's seen one of these before, right?
Oh yeah.
It's like a transform gizmo, I'm going to call it. It's the thing in your 3D engine or your 3D modeling program that tells you like how something is rotated or where it is or if it's like big or small or whatever, right? Yeah, so and it tells you which direction is up and which is right and which is forward. Now it has all this sort of information in it. You kind of look at it and you go, oh yeah, I know what that is, and you understand it. And I'm here to tell you today, when you see the big scary grid of numbers, like a 4x4 transform matrix for 3D graphics stuff, they're like, it's actually the same thing. And so if you think like, oh no, I don't understand that, like part of it is like you don't have to. Like when I'm like thinking about how to use transforms to figure out how to do 3D math stuff, I don't think about the gridded numbers. I think about these things. And then at some point you might have to like write down some version of some math stuff, but you can think about this and then turn that into the math you want. So yeah, you don't have to do the hard thing. You can do the visual thing when you're solving a visual problem. And I think that's kind of an important thing. And to dive like straight into it, that like that I think everyone knows what every single one of these numbers in that grid does. I'm just going to show you. I got a bunch of interactive demos on here. So if I go past one and there's this demo thing in the corner and I don't do it, everyone like make noises and wave your hands around a lot or something. Yeah, so we'll pop over to the blog. Oops. Yeah, so here's a sprite on the screen, and if I drag it around the screen, you'll see that like it's only one column of those numbers that's changing. And this is a 3x3 matrix, is it's a 2D transform and not a 3D one, which has one extra row and column. But yeah, as I move it around the screen, only that last column of numbers is changing. And you'll see that like, oh, if I put it down over here, oh, now it's at oh. Should I wait? Yeah, so if I put it down here, like that last column is at 0, and every time I move one of these grid cells, it goes about 100. So I can go up, so like, okay, so that's not so bad. That's directly the thing. And then there's that last row that's zeros and ones. But yeah, and then so if I drag this red arrow, that's only changing one of the columns. I can distort the picture of the Earth. I can stretch it out. I can squish it down. Skew it. And it's only that first column, that red column of numbers. I apologize to anyone that's colorblind. I've tried to make sure that there's always a way that I'm referring to things that's not just color to code them. But yeah, and so when we measure that red arrow against the grid, you'll see that it goes over by 100 pixels and not really up any. And so if I move that up, say like here, now it goes over 100 and up 100. So that's all that means. And similarly for the green axis, that's the y-axis of the image. Kind of does the same thing. If I move that over there, now it goes 100 to the left and then 100 up. And that's all the transform matrix is it's this thing. It's where it is and where the arrows are pointing. And that's all the numbers in there. That's the magic. And so like I feel like I've described this to people before, and they're kind of like, wait, that's all it is? Like they expected it to be much more complicated. And nope, it's like the dumbest way you could think of like taking these arrows and writing them down. Yeah, and so you might think that you're like, okay, so, but I have like an engine and like it does that sort of stuff for me. I don't need to know any about that. But I'm going to try and convince you that like it's kind of a game dev superpower if you know how to use transforms and how to use them to solve problems and make effects the way you want them to work. Like for instance, there's this image that comes out of like a interview with Iwata about the Zelda Link Between Worlds. Where they were talking about like one of the problems we had to solve is so it has this top-down view of the game, but it's in perspective. So like there's a little bit of parallax as you walk left and right, and then I have a demo to show like why that exactly happens. But you can't just take a perspective camera and look down at a scene like that. It doesn't work. And so like I don't know if this was like made for the interviewer, but like I I suspect they didn't actually make the game this way. They were just like using it as illustrative purposes. But it's one of those things that comes up like in indie circles all the time. They're like, oh wow, you know, like that's like brilliant. That's how they did that. And like now everyone seems to do it, and it's making the problem way harder than it needs to be. Like for instance, like it wasn't exactly like a new thing. Like Diablo did a similar like perspective, like top-down view, like with parallax and everything, and it's the same thing. Yeah, so it wasn't something. It was just like described in a way that made it sound more complicated than it was, I think. And maybe it's even possible that like if you want to do like really weird perspectives, like Ultima had this like infamous one where like the map was aligned to the screen, but then up was this weird oblique angle that pointed off to the side. And I don't think people liked that, so just probably don't do that. But it's a thing that you can do. And then lastly, something I would point out is this isn't full screen. Oh, it's because I switched tabs, isn't it? There we go. And so lastly, getting stuff on the screen is only half the battle. You still need to like convert those screen coordinates, back, into the space that you're working in, so that you can, do player input. Whether that's clicking with the mouse and you have an absolute point that you need to like convert into, map coordinates or something like that, or if it's, like you have screen relative joystick commands where like you need to know when they push forward or up or whatever, like what does that mean in relation to the game. And game engines usually give you like a hodgepodge of like you can convert from screen coordinate pixel coordinates to screen coordinates, and then screen coordinates to world coordinates and world coordinates, but like you kind of end up with a problem that you have this long chain of like stuff that you can do that, and it can get kind of confusing. So with the transforms, the exact same way that you apply it on the screen, you can kind of do it backwards and get your input out as well. So I've found that to be very useful in a lot of cases. And then some examples of stuff that we've made where I feel like having an understanding of how transforms work was vital to like completing the project. There's a Phineas and Ferb game that we made 15 years ago, I think.
100 years ago.
Yeah, geez. This was before it was a web game that Disney. It was the first web game that actually, or 3D game that like Unity put on like as a web game. And like our contact at Disney was like, oh my gosh, we just played this like super cool game with like portals in it, and we're kind of just nodding like, oh yeah, yep, everyone played that like 4 years ago. But they were super excited, because they played Portal, and asking us like, can you put that in this game? And it was like, oh yeah, we can do that. I know how to do that, and I was pretty confident that we could do it because knowing how transform math works. And also, there's been projects we worked on where we did like mapping stuff. And so, for instance, just something simple like you put the mouse over a location and you use the scroll wheel to zoom in on that location. Like doing that with raw arithmetic is actually kind of tricky. It's really easy to just do it wrong over and over again. And I've tried on several occasions being like, we're just starting from whatever. Like we can just do this, and it's confusing every time. Even though there's just like some multiplication and some addition, it's really easy to get it wrong. And on top of that, one of the projects we worked on for a company was we were making basically something kind of like Google Earth, where it was global sized data, and so we couldn't use 32-bit transform matrices. We couldn't use 32-bit math to do it. It didn't have enough precision, because once you zoomed in enough to actually like see buildings and stuff, when you would try scrolling and moving around, it would like move like a couple meters at a time, and it was really, the input was really chunky, and it was bad. So like that was the thing that we were called in to fix. And first thing I did was, well, okay, I'll just write my own transform stack using 64-bit numbers. And because I knew how to do the transform stuff, I was able to like work through that. And then lastly, another thing we did like 15 years ago is we made an iPhone game that had shadows in it. And this was before like mobile GPUs had shaders even. And so like I got the GPU to render the shadows for us, but without having make the CPU do all the work. And the way I did that was with transforms. I used some transform tricks to do it. So, and then a game we released a few years ago was called Verdant Sky. I'll just play this now because the first time it runs through, it looks like crap. Although, I actually loaded the high resolution version this time. Full screen, come on. not let me full screen. Anyway, so this is Verdant Skies. This was Andy's big game mostly that he wanted to make, and you can see it's kind of doing the same like perspective effects that like that Zelda game did, for instance. It's clicking work. Yeah, so it did that, and we used some transform tricks to make that easy, and then see if I can pause it without skipping to the next scene. You'll also notice that there's reflections. So like the trees are reflected, or like the plants over here have reflections in the water. And they also have shadows. Like you'll kind of notice like around here or so, like a bunch of the sprites have shadows on them. And to render the perspective correctly, as well as render the shadows and the reflections, we just use a transform trick. They're all rendered the exact same way. Actually, we have a demo of that. I didn't forget. Let's load. So some from an old blog post we made that yeah. So this is like the custom perspective with the custom. Oh boy, that's kind of slow, isn't it? You can kind of see there's some parallax in the trees as you scroll around or as you move around. Yeah, so it's got a little bit of perspective on it. Otherwise, it's kind of like a top-down perspective. It looks kind of alright. But here's what happens, if we just use like regular, orthographic camera and we tilt it down so that you can see objects. Everything gets squished, and if you think about it, it kind of makes sense because if I've got this thing in front of me that's standing upright, if I'm looking straight on at it, like I can see it at full size. If I'm looking straight down at it, it's just I'm looking at a pole basically. And if I'm looking halfway, it's sort of halfway in between, right, where it's kind of squished in size. So that's what you end up getting when you do just a straight orthographic view, and that's why you need to tilt things back so they meet the angle of the camera. And if you do it with a perspective camera, it gets even worse because things at the top of the screen, you're looking at an angle like this, but as they come up, more to the bottom of the screen, now you're looking straight down at them. So like as I walk through these trees here, like that's in perspective, but it's not what we want. Yeah. So then with just some transform tricks on the camera, we don't have to modify the objects or the scene at all. We can tell it, oh, actually, that axis that makes things be up, let's just align that with the camera, because it just changes that axis on that on the camera. So then things stand upright, but doesn't have the perspective to it. We could also do the cursed Ultima perspective and have things go off like oblique, and it's probably really hard to see on the video because it's streaming kind of bad, but there's perspective on that too, so it's the weird oblique projection with perspective. So yeah, so that's one of we kind of like solved all the like the problems with the perspective, drawing the shadows and the reflections. All of it's sort of just like this one trick where we just replaced one of the columns in the camera matrix basically. All right, gotta make this go full screen again. Come on. He thinks it is full screen. Whatever. Yeah, okay. So maybe the question. Yeah, you could call it that. You could refer to these as basis vectors. So the whole thing, you could say it's like a coordinate basis. Yeah. I mean, there's a bunch of names for all of this stuff. So yeah, okay. So as like a good example of like why would we use transform matrices? Like the idea that like if this is a transform and it's very visual, that's great. Like why do we want to like put them in a grid? Why do we want to turn them into a matrix? And so like as a kind of a prime example is when you're rendering stuff in a 3D scene. We need a model here. Looks like we got platypus. They don't really do much though. Harry the platypus. Yeah, so there we go. So now, yeah, so we have an object in space somewhere, like the cube, and like we have this transform that's we model it so that like the origin is here, and we can pick a forward and a right and an up, and we can place that somewhere in space and move it around. But to see this model from a camera, so like if I stick this on me, now I'm the camera and I have a transform, and I need to like view this model. I need to figure out where it is in relation to me and in relation to the screen in order to be able to render it, right? So what you end up doing is you have a transform for the object, and you have a transform for the camera, and you can use those to exchange information between them. If you did this all by hand, you could be like, well, translating an object around, that's just like adding some numbers to it. That's easy. And scaling the object, I can't do it with the Perry because he's a real object. But if I could scale him up, that's just multiplying some numbers. That's not so hard. Like, why do we need to complicate this? And then once you do rotation, it's like, well, that's you do some trig, but then you just take those numbers and you multiply and you add some numbers, and now you can rotate the object. But you have to do like all three of those steps. Maybe, maybe an object will have like 2 or 3 of those, but this other one won't. Since you make it super flexible that every object has this different sequence of transforms it can do. Oh, and then you usually have like nested transforms. Like maybe you have like a transform on Perry's hand so that you can pick up and hold an object when he moves around. The transform in his hand moves too, but you can also move his hand separately from the rest of them. And the object should move with it. So now you've got the sequence where you got to go from that transform to Perry's transform to the world transform, and then you still need to figure out how to get into camera space by undoing the camera's translation, undoing the camera's rotation to get into camera space, and then you still need to figure out how to relative to the camera, like I can see that there's Eric is like sitting right in front of me, but like where does that mean he's on the screen? I still need to do some more math to figure out where he appears on the screen. And with matrices, you basically can represent any single one of these transforms with a matrix, but you can also represent any combination of them with a matrix. So you can just have a single matrix that goes from, the transform on Perry's hand for whatever, object he's holding, that goes directly, into camera space or onto the screen with just one of those grids of numbers. And that's the power of matrices. And then also, bringing back up the input problem, I now also have one transform. If I do it backwards, I can go from the screen or the camera or whatever back to like figuring out like if I wanted to like where is that how does that space relate to whatever the thing he's holding in his hand, which is very useful and very powerful. One other thing I was going to say, a big part of the reason why you don't want to do like that big sequence of transforms that changes every time for every object is models have like thousands, tens of thousands, millions of vertexes in them. You don't want to do that whole complicated sequence for every single vertex in that object. When you have a matrix, you just have these 16 numbers that you do some additions and multiplications, and the whole process is done the same way for every object in every circumstance, which makes it much easier to write the code to do it. And even if you're not writing the code, it's still much easier to understand what's going on then. So we've sort of already talked a bit about like coordinates and 3D spaces and stuff, but like just to be thorough, vectors, they're basically just lists of numbers. So in Gamedev, we use them to represent 2D or 3D coordinates. They can be a position of something or a direction. It's like, for instance, if I want to point this over towards Anthony, like I can move it, like actually that's bad because I'm going from here. If I want to point to something infinitely far away, like the star Polaris or whatever, like I just pointed at the star. It doesn't really matter where I move this; it's still pointing at that thing that's practically infinitely far away. So that's a direction that I would measure. It doesn't matter where it is, but a position on the other hand is has to be in a specific place. And when you move it around, it changes. So those are the things that you'd store as a vector, position or direction. And in linear algebra, like vectors are a much more generic thing. You use them to solve all sorts of different problems that we don't care about. So, we don't need to talk about that. We don't need to talk about the broader implications of, how linear algebra makes that stuff complicated. And then to understand how the math of transform works, we only need to know 2 things: addition and multiplication. That's it. But we're doing it on vectors, so we don't have to do like arithmetic exactly, like with numbers. We can do it visually, which, I think is better. So if I go back to the blog here, I've got some widgets. So to add two vectors, you basically sort of just make a box out of them, right? So like this, to add selected the text on it. So to add this vector A to the vector B, these are directions, that we're drawing as directions. You basically just take one of the vectors and slide it down onto the other one. So, go from the tail to the tip to the tail to the tip. And that's your new vector. Like you kind of go across the diagonal. So for whatever vectors you're putting in, you're sort of just drawing a box and taking the diagonal. It doesn't matter what we do. We can kind of see that they're always just drawing this box and going across it. And like regular numbers, like if you have 5 and -5, they're sort of opposite but equal, and they cancel each other out and you make 0. We can do that with vectors too. If we go in the opposite direction at the same length, you end up with a vector that's 0 length. It's sort of the same thing. It's kind of a 0 value. And then when we multiply vectors, in this case, we're not talking about multiplying 2 vectors together, but we added 2 vectors. We're just multiplying a vector by a regular number. And really all you're doing there is you're stretching it out. I mean, you're making it, 2.5 times longer in this case, right? So whatever I do with the vector A, it just makes it 2.5 times longer, which similarly with the addition, I mean, you can kind of just imagine, you put, 2.5 of them on the end of it, and they all point in the same direction. So there you go. And that's all you need to know to understand the rest of the talk, if that's not so bad. Yeah, so then we can kind of put those together into a coordinate space. So like when you measure, like XY coordinates of something, like you might think, okay, so it's at 3, 2, like the X value is 3 and the Y value is 2. And you kind of think of that as just being that you have a vector that tells you which direction the X-axis points in, and a vector which tells you which direction the Y points in. You just do 3, you stretch out that X vector, so you have 3 of them and 2 of the Y vector, and add them together. And now you know where, the result is. So we can pull up a interactive demo of that as well. And so the fun thing here is, it seems kind of silly that like, okay, if you had graph paper, you just sort of like count the grid cells. Why do we need to make this complicated with the arrows? But the arrows can be anything. We can like make a grid that looks like this. And we can still measure, this goes 2 over on, like the X grid, and then it goes 2 up on the Y part of the grid. And it still is a perfectly valid way of measuring things. And we can move this around, and we can make it look like an isometric map, maybe. Something like that. And we still have like a coordinate system we can use to figure out, like in isometric coordinates, okay, yeah, if we go 3 this way, it's not exactly like the X-axis of the screen anymore, but it's the X-axis of your map, maybe. You go 3 that way and 2 that way, and there you go. Now you have this coordinate space for an isometric game. We do have one problem with this, though, that's if we're thinking about it as being a transform, that like, oh, we can do all this, fun stuff like make isometric grid or whatever, we're sort of missing an ingredient in that we can use that grid to rotate things, and we can scale them, and we can skew it, but we can't actually make it move around. We can't translate it. In order to do that, we're like missing an extra ingredient. And translating things, we just need to add something to it. But what would we add to it? That's sort of, we get into something that's called homogeneous coordinates. And kind of the idea is that like we want a mathematical way, like if we have if we can store vectors that have positions or directions in them, we want to have a way to be able to tell the difference between the two. Because you can move the point and it's a different position, but if you move the arrow, it still points in the same direction. We haven't changed the direction of it, and that's the thing that we wanted to know from that. And so what you do is you add this extra coordinate on the end, that's the W coordinate. And if you want it to be a direction, you set the W equal to 0. And if you want it to be a position, you set it equal to 1. So it's sort of just like a Boolean flag. Is it one or is it the other? It gets a little bit more complicated than that when you do like perspective stuff. But for now, you can just imagine that's all it is. And that's why when we did the 2D matrix before, it was 3 by 3 because it had this extra W on there. When you do 3D matrix, it's 4 by 4 because you have an extra column for the W and an extra row for the W's on the end. So now we kind of have everything we need to do to transform both directions and vectors. So for the point here, if we want to, transform that point, well, let's start with the direction. So again, we just like multiply the x-axis and multiply the y-axis, add them together, so we draw the box. So that gives us that d vector for our direction. And then if we want to turn that into a position, then we just have, over here we have that w-axis, and we multiply that by 1, because when it's a point, that's value is a 1, so it adds it on. And then you can kind of see here that it's, we're just kind of making a box with this w and the d vector, and it tells us that the location of that point is there. So it's just this extra thing where you're saying, do I add this extra translation onto it or not? Because you don't want to translate a direction. It changes the direction of the direction then. And now we finally get into so why do we have this matrix form? Why this dense matrix form? And so if we take and we write out, some actual numbers, you don't actually have to care what the numbers are. This isn't a math talk exactly, where we need to do like math. But like visually, we have, again, so we're just multiplying x by 1 or y by 1.5, and it's a point, so we add on the w. And then we filled in the number versions of this. And you can kind of see that, like, okay, so this is the same thing as we had the transform matrix before, where we have our, that's the value of our x-axis, and that's the value of our y-axis, and that's the value of our z-axis, but they're all like mixed together. Like, we have, the the x-coordinate there, and the y-coordinate there, and they're all mixed together, and it's confusing, and it's difficult to write the code that way, because you always have to be writing out this whole thing all the time. So all the matrix does is say, let's just rewrite this, reorganize it so that it's easier to look at, and put the matrix, put all of those columns into one square. And then we take the coordinates that we were putting, multiplying each of those vectors against, and we put those into one thing, and we make it this vector, this column of list of numbers here. So all it is organizing the stuff for us. So we have one thing that's our matrix, one thing that's our matrix here, and one thing that's our vector here. And specifically, I sort of drew this, in the right to left way, because when you've written the math this way, you kind of think of like the vector as being transformed by the matrix and ending up, when you do variable equals thing times whatever, it's moving to the left. Which is going to be, I'm going to repeat that a bunch. It's going to be helpful. So when you have one of these matrices and it does some sort of transform, well, what kind of transform can it do? And generally speaking, it's what you'd call a linear transform. And for the purposes of our game dev stuff, you can think of a linear transform as if you have a 3D model that you have, or an image that you transform, and it has lines in it. Those lines should stay lines. They don't get curved, they don't get bent or twisted or warped. And if you have two parallel lines, they should stay parallel lines in the output. So like the top of top and bottom of the box should stay parallel to each other, even if you skew it so that like over here, if we skew it so that like the other parts are at an angle, the top and the bottom are parallel, and the two edges are parallel there. But other than that, we could translate, we can rotate, we can scale things. We can scale things by negative amounts so that it flips the direction, on the x, while squishing it on the y or whatever. So you can kind of translate or scale unevenly. And then skewing, it's a good example. It's good for like 2D animation stuff, but doesn't really come up that often, I feel like. Most 3D engines don't really give you a way to do skewing exactly, but it's a thing you can do. Yeah, so then the other thing is, because you can combine these transformations, you can kind of get yourself into trouble where like you've done all these transformations and like technically they're all the same thing, they're all the same complexity, but I find it like extremely hard to think about these sort of things without simplifying them down a bit. And specifically what I mean by that is, like, say we have this sprite of this spaceship here, and we wanted to move it over here and rotate it, but it has an anchor point. So we want to, like, this is the image bounds of it or whatever, and we need to, use the anchor point, and we want the anchor point to move there, and we want it to rotate around the anchor point. So like the way that I would think about this is the first thing you need to do is always think about the origin. Where is the origin? Because the origin is the thing that actually does the simple transforms. So first thing we would do is we would, use this transform to move it over here, so that the anchor point is at the origin of the new coordinate space. And now that's our first step. We forget this axis. We erase those with a pencil or whatever, right? Forget about them for the moment. The object is just there now. We've applied that transform. And then the next transform we apply would be to rotate the sprite, for instance. So we can do that, and it rotates around the origin. So like you stick a pin right at 0, 0, and you rotate it around that. And then again, we can erase these lines. We did that second transform. We can write down whatever we need to. It's part of the sequence, but forget the lines are there for a moment. And then we take the origin and we move it to the new place with this new transform. And breaking them down into simpler steps makes it way more easy to visualize what happens, because it's easy to get mixed up with transform stuff, because the order that you apply them in is important. It matters a lot, right? It's like similarly here, if we started out with a ship in the corner there and we rotated it to the right 90 degrees and then we moved it up, well, it would end up above it and looking to the right. If we did those operations in the reverse order and we moved the ship up first and then rotated around the origin, because think about the origin, it ends up down over here, pointed in the same direction. It's pointed in the same direction, but it moved to a different spot. So we have to do the transforms in the right order, and by doing like a simpler series of transforms, it makes it much easier to think about, like, so where will it go next? How will it move? How will it do that sort of stuff? Because again, to me, this is all like a visual problem. I visualize it in my head to figure out what you need to do, and then write maybe some code that actually like does that thing. Whether that's hooking up transform gizmos in Unity to do the thing for you or not, like it's still the same problem that you're solving. And then we sort of talked about how you can combine transformations with matrices, but how exactly does that work? So the idea is that you can multiply a vector by a matrix. You can also just multiply some matrices together. And thinking visually, what you're really doing, so like over here, if we have this hierarchy of transforms, like this one's our root coordinate space, or our absolute coordinate space, our global coordinate space, or whatever you want to call it. And then we have a transform that's moved over here and rotated in a certain way. And then it has a child transform that's over here that's moved and rotated in a certain way. Part of the transform that that's hidden from you, a little bit of hidden state, is that they're nested, right? Like this one corresponds to this. There's this implicit arrow that points from this one into this one, and then from this one into this one. So what you're doing when you're combining the transforms, when you're multiplying their matrices, is you're saying, I want to go from this transform directly to that one. So you're drawing a new arrow. The arrow is sort of implicitly part of the transformation. And so when you're measuring the values of the axes, like those were the numbers that were showing up on the screen in that one, what was happening is we were measuring the arrows and the position of that relative to this one. And this one is measured relative to that one. And so another way of thinking about multiplying the matrices, is that you're converting the measurements of this transform, this gizmo, from the space of this one to this one. And we already know how to do that, because if we apply a transform to direction or a point, it converts it to a new space, right? That's the whole point. We can convert things from one space to the next. And so all multiplying a matrix is like you have the columns that are the directions and the position of the values in it. So like the matrix on the left, you kind of you plop that down there, and then you take each of the columns, which are one of those vectors, one of the directions of the axes or the origin, and you do them one at a time, and you multiply them against that, and you put it back over there. That's all it is. You're just kind of taking the columns one at a time. So the first column we multiply by the matrix, and we put it in the first column over there. Second column, third column, same thing. It's a little bit dense with all the numbers there, but it's nothing like you haven't seen so far exactly. So then in like a more concrete example, like if we think about the rendering example again, we have the standard way that pretty much every game engine and like rendering program has done this for decades at this point, is using what's called the model view projection transforms. And so like you'd make a matrix for these things that were the object that you want to draw, it's your 3D model, that has a certain transform to it that you can express that as a matrix. The view is sort of like the opposite of the camera's matrix. Where like if I am the camera and I'm looking around, this is the camera matrix. It tells me where I am and which directions I'm looking in. The view transform sort of goes the other way, but we don't have that yet, so we'll have to think about that. And then the projection matrix is like, okay, so I'm looking around and I can see where people are in relation to me, but I need to relate that to the screen. And you can kind of think of that, like when photographers do the thing where they hold their fingers out and they frame a shot. That's the projection matrix. It's saying like there's things out there and I can see them, but I need to figure out where the corner of my screen is and how big things are scaled. So like if I want to zoom in on something, I'd put them close together or like a wide shot. That's just like one more like scale and translation that you're doing, that you're going from those 3D coordinates to the screen coordinates. And then again, think about things moving to the left. So if you wanted to apply these, you'd take the model transform, which converts to global space, and then you'd apply the view transform, which converts to camera space, and then you do the projection, which converts to screen space. And so you got all those on the end. And I put all the parentheses on there to see that like, okay, that's the order you want to do. You want to think about moving right to left through there, which is sort of written backwards from like the order that you apply them in, right? Which again, I think is just like helpful to just rigorously just think about that. Like you got to do it that way. It's always right to left. Visually, I think of it, moving that way as a transform, but we can't switch the order of transforms because that changes our transform if we change the order of the steps, but we can move the parentheses around. We're allowed to do that. So we can just multiply these three matrices together, and now we have, that's how you get the matrix that goes from coordinates for a model directly to the coordinates that you're going to use to plot something on the screen, to draw it on the screen. But now we got to talk about this view transform, because if the camera transform, its arrow, its hidden arrow, points from the camera to that one. So it means this converts coordinates from the camera to that, to the global coordinates, and we need to go the other way around. We need to convert from, because we're taking the model, converting it to global coordinates, and we need to go this way. We need an arrow that goes the other way. And so to do that, you need a matrix inverse. And I sort of like said, there would be no like fancy math, it's just arithmetic. The matrix inverse is a place where you actually have to do algebra. But you also don't really need to know how it works. Yeah, that's one of those things where you can use a library. It doesn't help you to know how to implement a transform or a matrix inverse by yourself. But you do already kind of know how to do one. If you remember from like algebra and like middle school, high school, two equations, two unknowns, that sort of thing. That's kind of solving the same basic problem. It's just that when you go like 2 or 3 or 4 dimensions, it becomes a lot of work. And so, yeah, records algebra. Yeah. And I would say 2D transforms are just like easy mode. And you see them everywhere. Like every 2D drawing API uses the same transform matrix stuff. It all expose the same thing. And most of them don't even provide like a fancy like high level layer to it at all. Kind of just because you just need these 6 numbers. And yeah, so before when we talked about like that with the sprite of the Earth that we could move around, we had those 3 columns, right? For the x-axis, the y-axis, and then where the origin is. And then there's always that 0 and 0 and 1 on the bottom. Kind of know what that means now, because it's like these 2 axes, they're a direction, so that w coordinate is 0, and then the origin is a specific point, so it has a 1. But because all of these matrices will always have 0, 0, 1 on there, they sort of, like everyone that does a 2D drawing API just ignores them, and you just hard code them into the code. So then you're left with, and they're almost always labeled this way, A, B, C, D, X, and Y. So A and B are what your x-axis is pointing. C and D is your y-axis, and X and Y is just the translation, where it is on the screen. And then if you go easy mode, these are the only matrices you kind of need to like memorize. That like your translation matrix is X points along X, Y points along Y, and then you translate by the amount, the X and the Y amount that you want. Scaling is just, you know, making the x-axis longer or the y-axis longer or both, and then not moving on X. Rotation requires some trigonometry. Like, I don't know, that's a thing you can look up or memorize, but also it doesn't move. And then skewing I threw in there for like completeness, but I don't think I've ever used that. You kind of just need, you know, those three. I do make one exception for a complex transform that's like kind of the quintessential one, that's kind of the only one you ever use in 2D almost, is if you want to scale something, rotate it, and then translate it, like a sprite, for instance. It looks like that. You scale this column, you know, for the x-axis, you scale, and it's the same like rotation matrix you saw before, the cosine, the sine, negative sign, and then the cosine, but you just add this extra scale thing to that column to stretch out that axis to make it longer or shorter, and then you translate. And because it's like a simple enough like formula, the pattern for it, I don't know, I just like memorize that one, because it's, yeah. In Inverting Expanse, I just have these all over the place where like, instead of like doing, you know, like rotate a thing and then translate it and then scale it, like, and doing it that way, I'll just write those, because usually you're only doing one or two of the things, and it's just easier and more compact to just write that. And then the rest of the code for all my demos, the interactive demos, that's all the rest of it. So you like 20 lines of code is all you need to interact with like any 2D drawing API. I find that to be kind of interesting, that it's as simple as it is. Yeah, so that's, yeah, 2D. I think people should try that at least once sometime. Like, make a JavaScript thing that just draws stuff, write the 20 lines of code you need to do it. I think it's a good exercise. But anyway, so before we talked about Verdant Skies, like how we did the, you know, like we did the camera perspective fix, and also drew the shadows and the reflections. Maybe now it kind of makes more sense about like what exactly is it that we did, because you know, when we have our camera transform, it's the view transform for it, that we basically just added an extra, you know, thing onto the view transform that says, oh, actually, that x-axis that you thought was pointing, you know, sorry about this one. So like me as the camera, you know, looking at this object that's standing straight up, you know, like as I'm looking down at it, you know, it's y-axis or z-axis, whatever, pointed straight up, and you just say, oh no, tilt it so that you're looking at it like square, right? So that's what we did. We just substituted the view axis in the camera to one that was tilted like that. And then when we wanted to draw our reflections, we just told the camera to render the whole scene again. Oh, and then just flip that vector upside down. And now we have objects that are all reflected and drawn the right way. And then when we wanted to draw the shadows, we said, oh, that vector that was supposed to be up, we'll let it fall on the ground, and we'll just like move it back and forth and scale it or whatever as the time of the day changes, and it changes the sprite into a shadow exactly the way it's supposed to, and the perspective works. Yeah. And so it was, all that was is replacing that one vector, that one column out of the camera to do it. And then again, some of those other projects we did, like the portals, when you want to render like through a portal, you basically tell the camera to render again, and then you take the inverse transform of the portal to sort of subtract its movement in the scene out, and then you take the opposite side, the other portal, and you say, oh, substitute that in, so you multiply that one, and at some point you gotta like flip it to over one of the axes. But so that was just like a couple of transforms that it multiplied in. For doing, you know, map zooming, it's kind of the same thing as like the ship sprite example. Wherever you have the mouse and you want to zoom it, you know, use the scroll wheel to zoom in there. You just you figure out where that coordinate is. You can use a transform to do that. You move that to the origin, zoom in on the origin, and then move it back to where it was. And that's how that's the easy way that I've found to implement map zooming. Otherwise, if you tried it with this raw arithmetic, it's the worst. And then the shadow stuff, we actually used a perspective matrix for that. It was kind of a cheat, but so it wasn't strictly a 2D transform. But yeah, that's all that was, is setting up some geometry that we never had to update ever, and then telling the GPU to draw it. And going further, there's like more stuff you can do with, you know, simple transforms. Like color, for instance. Like you can think of, you know, color as like a 3D space of its own. You've got, you know, like a red axis and a blue axis and a green axis, and there's this cube that's full of different colors. And you can use transforms to rotate those colors, to do like hue rotations, or, you know, yeah. No, I mean those are usually exactly what it says. Like you take each pixel and you add it to the destination, or you take each pixel and multiply the, you know, against each other. But you can kind of like think of them as kind of doing, like, you can do all those operations with transforms too. It's just you don't need them, if that makes sense. But like, for instance, like image and video compression, like JPEG and MPEG and H.264 and whatnot. They do a color transform. They take, you know, the red, green, blue, and they apply a regular linear transform, just like we talked about, to shift the colors so that you have one of the axes is the brightness of the image, basically, and then you have like two of those that kind of go across the colors to give you the hue and saturation. Like if you remember, like everything's HDMI now, but like component on TVs, you'd have those 3 video plugs that you'd need to plug in. There's like because the older video stuff, you had like the yellow, the red, and the red and the white for the audio and the yellow for the video. But then like at some point you had to start getting like fancier component TVs that had like the Y, the CB, and the CR plugs. And what are those? The Y is the luminance, how bright it is, and the CR and CB are those color difference values. So that's how that worked. The reprojection is kind of like a really cool, fun idea, that if you have like a scene that you want to do some really expensive, you know, operation on over time, like figuring out how to, like, the lighting, global illumination, like how light moves through the scene, you don't want to like completely recompute that every time. So what you do is you reproject it. If you remember, if you keep the last frame that you rendered around, as well as the last like model view projection matrix, you can say, oh, where was this pixel on that thing on the previous frame? It was right there. And then just use that value again, because you just read it out of the texture. And it's nothing more than just sort of like rendering it a second time. And then you can use it again and modify it a little bit, accumulate a little bit more light. So that's kind of how that works. And then inverse kinematics is kind of like a fun thing where, like, oh, if I need to reach out and grab this parry and my arm is like this, I would figure out, like, okay, let's take this transform of, this arm, and I need to get this point, the end of my hand as close as I can to the parry. So you can figure out that, oh, given its coordinates, I need to like rotate like that. That's the closest I can get. And then you can do this part and rotate that to get as close as you can get. And then that's a lot. So you rotate and then you rotate. And you kind of like keep iterating. And just by like looking at the differences, the amount of error that you have, how far off you are, using your transform to figure out like which direction to move and how much. And you just iterate that a few times, and then you figure out how to move the whole arm without computing any angles. That's kind of like the neat trick there. Yeah, so then there's like a lot, you can go a lot further with this, and the math does start getting more complicated, especially when you start doing stuff with like 3D perspective, if you really want to know how like that part works. Because remember how I said, linear transform is like something where you have parallel lines, that the lines will stay parallel after the transformation?
I remember.
Yeah.
But I read it earlier.
The trick is, you apply a non-linear step after you do the transformation, that you take that W value that's supposed to be only 0 or 1, and you divide by it. So as things get further away, the W value gets smaller, and they get divided by a bigger and bigger number, so they squish towards the center of the screen, which makes them look smaller and get and that's the perspective part. You don't really need to know that to have like a super useful experience with transforms, so that's just where it gets more complicated. Shadow mapping is kind of another like fun example where the idea of shadow mapping is you render a scene from a light's perspective, but you don't render the color. You just render away how far everything is from the camera. And then when you do your actual rendering, so like if I rendered from over here and saw, okay, that's how far away certain things are. Now I'm over here rendering the real camera of the scene, and I can figure out like, oh, that point that I rendered in that shadow map. I can figure out like where it's supposed to be from this camera's perspective by just doing a matrix multiplication and then checking, oh, is that farther away or closer than the thing that I'm looking at? And if it's closer, then you draw it in shadow, and if it's farther away, that's being lit by the light. So it's a matrix multiplication and equality check. Yeah.
So does it mean, like, I've heard I usually hear matrices talk about in linear algebra. So does it mean can matrices only encode linear transformations, or does this actually break that? Like this like there are in a matrix?
I mean, no. The whole point of so linear algebra is all about linear systems. In linear algebra, that like what makes something linear is a little bit more generic. It's not about like drawing lines exactly. It's basically that you have things that are like series of like multiply and add, multiply and add, multiply and add.
So like so in this case, then like it is still a linear transform. It just breaks what I was going to say.
It's a linear transform up until we do the perspective divide. Now it's not linear anymore. The thing that you draw to the screen is no longer linear transform technically.
Okay, so is that last step that's not a matrix?
It is not. Nope.
Okay, so
You're just taking each like vertex that you calculate in the model. Like you end up with like here's an XYZ and then also a W value. And because it's a perspective transform, you'll end up getting something that's not a 0 or a 1, and you divide by that value.
so is the projection matrix obviously more perfect, and like the infinite perspective is so separate from non-matrix thing you do?
No. Okay. So the difference is that like all the matrices I showed on screen, when I put numbers in them, always like that last row is 0, 0, and then 0 is followed by a 1 in the last column. The perspective projection matrix doesn't have a 1 in the last column; it has it somewhere else. Or you can kind of think of it as being, when you draw perspective stuff, you have to like you put a point somewhere and you make all the lines converge towards it. You're kind of telling it like where do things converge to. You make that part of your coordinate, if that makes sense. Yeah, and then there's all like weird stuff that you get into like with homogeneous coordinates, like when you divide something by 0, like you're sort of getting infinities, which doesn't make sense once you do that dividing part. But before the dividing part, all the math works out like great, and it makes it much easier to like deal with things that are infinitely far away or infinite planes or infinite lengths or stuff like that. It oddly makes all that math sort of just work, which is confusing and bizarre and amazing. And then you get stuff, like stereo vision, like how do you work with, two different, for like VR, like how do you work with like multiple projections and stuff like that. And then you get like computer vision stuff, which is the opposite of rendering, sort of like you're seeing objects and you're trying to figure out information about them. And that's where you get like interesting things that like, oh, from like one view, like I think of, like something, it's like a ray that shoots out of my eye. Like I wouldn't be able to see it because I'm looking at it end on. But like, if I move over slightly or look from my other eye, that thing that was invisible to me because it's a single point is now a line. And so you use like a lot of geometry like that to figure out computer vision problems, which all the same math, and it's kind of interesting, I think. Questions?
That perspective depth is
What?
How is the perspective
What do you mean? Like before you do the divide?
divide by?
I mean, so you have an XYZ value, but there's also that W. I mean, you
How do
take.
you know a number to divide by?
Oh, that's okay. Your perspective projection matrix computes, like the let's come up with a good example here. Yeah, okay. So here, if we look at our, matrix multiplication thing, like you can think of, like the
Well, first of all, can you
not that one actually.
refresh me on what the numbers in the columns are supposed to be?
Yeah, okay. So like as a concrete example, so here we have, an affine.
I ran the broken.
I'll gesticulate instead. Okay. So yeah, so like we have the like the x column, the y column, and then the origin, the w column, whatever you want to call it. These are directions, so they're zeros. That's a position, so it's a one. And if you do the math when you are, what am I trying to say here? Okay. So here's what I'm trying to say. So like this part being the one, when you do the multiplications, you take this and you flip it up there, right? And you multiply each one of these. When this part's a one, like the only thing you'll ever get out, because these are zeros, it doesn't matter what this value is. Those two values are always zero. So adding nothing, and then you get 1 times 1 or 0 times 1. It's one or the other, right? If you change this bottom row, so it's something else, now you start like feeding the x values or the y values into the amount that you're dividing by, right? You get a different w values, not just 0 or 1. So like a regular perspective matrix would be like, like I'm, as the camera space, I'm looking down like the z-axis or looking up the z-axis, depending on, which engine you're talking about. And so you put, like the z column would have a value in it instead of this one. Does that make sense? So the further away you get, the bigger that w value gets, and you divide by more, and it squishes it more towards the center of the screen. It makes it smaller. Yeah, I mean, it technically works with 2D stuff, but I don't. If you just get like I don't know why you'd want to do that. I don't think there's any practical use for it.
At
Yeah.
the very beginning, we talked about 2D. There's, just saying you can do it. But later on, we talked 3D. It really does matter what order you do the transformations in.
What matters in both? Did I say it doesn't matter in 2D?
Well, when we're introducing just like very basic A plus B equals C, kind of the A plus B equals C.
Oh, like on the vector addition stuff.
Right.
Okay.
Well, but we were talking about transforms. But like rotation, I suppose it would depend, like if you had a car, it would depend on what order it was in relation to itself.
Yeah, kind of, right?
Okay.
Is that a question?
No, I'm doing the order is different, right? If you go this way, then this way, your hand's pointing down. If you go this way, then this way, your hands are pointing that way.
Yeah.
So for multiplying rotations together, the order will matter. When you're doing vector addition, that order doesn't matter.
Well, and to be clear, vector addition isn't a transformation, right? Like vector addition sort of just like regular addition, but you do it twice or 3 times.
I was more going off the thing of I was trying to get my head wrapped around it, just explain the rotation transfer.
Yeah, and related to that, like one thing I will say is like I always like to think of things as like simpler transforms and like make a chain of them than trying to do one big complex thing and think about how that works because it's really hard to visualize. It's often possible that like your simple test case, it's possible that like switching the order of transformations will give you the same result. Like if I take a step forward and then I take a step backwards, I end up where I started. But if I take a step backwards and then take a step forwards, I end up somewhere else, right? Sorry, I end up in the same place, but I took a different path to get there. So it's easy in like simple cases to trick yourself into thinking that it's fine, that you did it right, and then later on it doesn't work, and you're going, well, I thought this worked. So yeah, again, I think it's important to use simpler transforms so you can think about the process.
So when you're running shaders, you have access to a W value, the same W value.
That's the one. Yep.
And what does it code? Various things that use it so that.
So generally speaking, it's going to be more or less the same thing as the z value, because again, like when you've got the camera transform, it points down the z value. The difference is the z value kind of goes from the near plane to the far plane you have set up on that camera, whereas the w value always starts at 0 at the point that the camera emanates from. That's kind of how that works. It doesn't have to work that way, but it's not useful for it to work any other way, if that makes sense.
So living with W1. So W0 is random point camera. W1 is it or?
No, I mean W1 is some arbitrary distance away from you. I mean, it depends on like what scale things end up on the screen or whatever, right? Because 0 is you divide by zero. The small is you divide by a smaller and smaller number as you approach 0. The thing will get bigger and bigger and bigger, and as it gets farther away, you divide by a larger and larger number, and it gets smaller as it gets farther away. Yeah. So 1 is sort of just like an arbitrary distance that depends on the other, like how wide your field of view is. How yeah, there's a lot of factors that.
I guess so. Like the W value is like tend to go from 0 to like 1,000 ish or something. Like they're not actually there specifics. So the W goes from 0 to some like
Uh,
large number.
yeah.
Question. I think like you get down, you set the near far.
I mean, again, the W value always like at the focal point of the camera or whatever is 0. The near and the far plane, the Z value will have that. They're similar, but again, yeah, they're more directly perpendicular, so it makes a nice projection. You can do what's called skew projection matrix, where you can think of it, like okay, you have like a regular regular perspective projection where as things get further away, they sort of like go towards the center of the screen. But then you can think of like, oh, what if I crop that part of the image? Now, as things get further away, they go towards the corner after you cropped it.
I was gonna ask about this. You totally dodged the view camera projection, right? Did you have a camera?
Yeah. Okay. So maybe I didn't explain that super well. So the camera matrix is this one that's measured in this coordinate space and it converts coordinates that way. The trick is to get the view matrix, you take the camera matrix and you invert it. And that switches, like you can see there, that's what switches the direction of the arrow. Because the arrow is sort of like the hidden part of like the gizmo that is important to describe the motion of the coordinates being transferred from one space to another. And by inverting it, like you switch it back around the other way. So otherwise you'd have to like define everything in the world in relation to the camera, and every time you move the camera, you'd have to move all the objects, which like you don't want to do that, right?
I see that the view is the inverse of the camera with the literal cameras. I gotta type about movies.
Ooh, and maybe like a thing, like to your use case of, like, I was like, oh, like when you were struggling with your shader stuff with the space stuff, I was like, you need to use transforms because you were just using like raw arithmetic for it. Like shaders are like a case where like you don't have gizmos, you don't have like you just have to understand how the transforms work to be able to write the shader code to do things. So that's like, yeah, a really important place where you can't avoid understanding the transforms. And again, you don't need to understand the math. You just need to understand the visual and how that maps to the columns. Each one is an axis and then the origin. Yeah, yeah,
It took a while to figure out.
yeah. Oh, yeah. That's I think just like there's the local pizza place. Yeah, Carboni's and Pizza Pub.
Go ahead, Sam.
Oh.
It was a good question. I'm learning so much today, and I'm enjoying this. I'm trying to bridge the gap from like I understand the 2D space and like skewing, and I get the C vector. I'm trying to bridge the gap like for how I'm trying to visualize how like 3D space in like say a 3D modeling program or game engine to like what the matrices look like in that is
Oh.
let's say like the third axis could be because the x and y axes make sense to me visually. Okay, there's just another one.
So yeah. So yeah,
Okay.
the x-axis, the y-axis, the z-axis, and then that's the w-axis or the origin, whatever you want to call it. And then of course they have an extra row in there because they all need a z coordinate for each one of them as well.
Okay.
Yeah, sorry, I
And
guess I
what's
didn't really
that
explain that
extra
part.
row?
On the bottom.
Okay. And that's okay.
And then that's the W values for all of them. So that this column is a direction because that's a 0, because that's the x-axis, the y and z. And then this one's a point because it's at a specific place and not a direction, like for the origin of the transform.
So so you have a model, right? It has a position at some x, y, and z coordinate that is some vector away from the global origin.
Mhm.
That column
That
is the transform from the
translation,
global
yeah.
origin. It's from the global origin to the origin of that model.
Correct.
Then everything else applies the transformation, scale, rotation, etc. on that new space.
Yep. Exactly. But yeah, again, it's sort of just like the simplest way you could think of like writing down any numbers about this is like, oh, what if I just figured out what direction that was in and that? Yeah. So like
So that last column is like the global difference.
yeah, they like the translation, like you know, like
Translation, new origin.
should have had 2 of these so I can hold up 2 of them. But like, you know, like we'll do a left hand rule here. You know, if like this is it, you know, like yeah. So it's the translation from here to here.
Because when you have a model, everything, like when you create the model, all the vertices are related to the other vertices within that projection, right? Within that unit. And so moving around in space, you're going to have a translation vector pointing to where it is in the new location. And everything else keeping in relation to those, like Harry's hands, his hat, right? Those all are in the same
Coordinate space.
ratio or coordinate space associated with themselves.
Oh, so many more questions. Sorry.
Like quaternion notation, is that just like the same W values that we're talking about, or is that like separate?
No, quaternions are much more complicated. Although they're a bit less mystical than people think they are. The x, y, and z value are like, so you can imagine Perry here, and I stick a pin through him, and like the direction that points in, that's what the x, y, and z in the quaternion are. The w value is 2 times the cosine of the angle that you rotate around that, or something like that. And then you take all of those values and you normalize them. So it's yeah, quaternions are actually like kind of complicated and hard to reason with, but like the actual representation of them is basically an axis and angle. Josh?
So, still trying to wrap my head around what exactly do you get when you're multiplying transforms together?
Nope, not that one. That one. Okay, so when you're multiplying transforms together, you're basically saying, you know, so this is our global coordinate space. That transform is telling us where those different axes point. And this is, you know, a game object or whatever, right, in our scene. And it's been translated away from the origin and it's rotated a bit. It has a child transform that's over here and it's rotated a bit. And like the relationship of these transforms is the arrows, the bendy arrows put together, right? So like if you have, you know, a point or a model in here and you apply this transform that's represented in this gizmo, it gives you the coordinates in its parent space. When you do it again, you get the its coordinate space. When you multiply them together, it combines both of these sets. So you get this arrow that goes from one to the next.
Okay,
And the
are the multiplication and addition?
yeah,
Addition.
it's you can kind of think of it as like honestly when I think about like inverting transforms and multiplying by them to like undo something, that's sort of like subtracting out the transform of a thing. Honestly, it just comes down to like nomenclature. They didn't come up with a new symbol to being like what does it mean when we compose transformations together. They just said we'll just call it multiplication, and it has these new rules like you can't switch the order of the values that you're multiplying because that changes it. But you can move the parentheses around, so that still applies like regular multiplication. Like, why did they use the same symbol? I don't know. It's sort of confusing that it's called multiplication when it's kind of different, but it
Not cross.
kind of similar.
Like they
Yeah.
already made up all the weird symbols.
Yeah.
Operations.
And in a way, like a lot of the stuff is like, this is a dot product. I'm taking these three things and multiplying as those three things, and I'm adding the results together. It's just some of them are vectors and some of them are like it's sort of turtles all the way down with linear algebra. It's like the same concepts just applied recursively.
Just thinking like it's possible matrices versus not. So similar to the perspective stuff, there's a cool effect I've seen. I'm sure you've seen it where if you just take the y coordinates of all the big things and make them lower the part of the arrow from the camera, you get a cool like spinning world looking thing. It's like Minecraft shaders do, whatever. Is that so? I've done it myself in a shader. I didn't use matrices. Just really obvious. Just lower the y value thing, whatever. Right? Is there some way to do that with matrices, or is that like a totally separate kind of thing?
If you lowered the y value in a linear fashion, it would just make it look slanted. So no, that's a nonlinear thing that you'd have to do that, so that it looks like the y values are on a curve as they go away from you.
What's the thing with Zelda that they needed?
Oh, I mean, I don't think it's so much of a what should they done it. I think it was just like when they had this interview, they made it sound like this like they solved like this way more complicated problem than they did, and I think it was just like a lost in translation where they were like I wonder did they like I don't think they actually like made this.
A funny angle.
Yeah, I don't think they made their artists model that stuff. That's kind of what I'm getting at. I think it was just like they described the problem and someone like made an image to show what they meant.
Because I've taken screenshots that look like that with virgin skies for that like illustrative purpose. Just like, oh yeah, this is what it kind of looks like. Not really, like if you were to look at it with a different matrix. Camera matrix.
And I don't know, maybe they did, and that was the way they solved it. They're like, oh, we just need to tilt stuff, and they went, oh, we can do that. I mean, it works. It's not like it's wrong. It's just it seems like there'd be a lot of extra effort to like model everything, and yeah.
Maybe to clarify what that image is about. So like, is it actually impossible to make that image without actually doing model it? Like, because like obviously we know how to transform things with a camera, but like, is there a way to like show a camera that's showing how it would look if you weren't looking from the camera?
Oh, absolutely, yeah. You just like when you it's that is itself a transform that we're applying to this, right? We're just we're like taking things that should have been up and we're tilting them in a certain direction. We're just modifying one of those axes.
But then in that case, direction is some other point. Like, well, what would actually be the order of operation of that? Would like scale it as though the yeah.
I mean, I don't know how to answer that question exactly. I'm not sure what the question is, but like, yes, you would have to like do that transform at the right place in the sequence for it to work, and that is like a thing that you have to think about, figure out where it should go, but
Because we did some of that stuff in perspective. Sure.
oh, yeah, I mean, kind of.
Yeah.
Like the oblique, yeah, this one, like the oblique.
It's like
Tilting.
What happens if you change it in one axis? What happens if you change it in two
This one.
axes?
Yeah, like it's kind of doing this is what you're asking about. Like it's tilted in a different direction than the camera looking at it. It's tilted in also in an additional direction.
Yeah, we picked a specific angle. Yeah, we picked a specific angle for bird skies.
Well,
To be clear in this demo,
part of the reason why we did it that way is like originally you did just like have like a script that would just like tilt everything and that was fine. But then you were like, oh well, we want to like for cutscenes we want to like animate the camera a little bit, and that meant like oh no that script that just like tilted them all, it needs to run every frame that happens. And when you have like thousands of game objects in the scene, turns out that one script that just changes the rotation of every object was like almost all of the CPU time. So that was the fix. Is like, oh no, we can just do this with transform matrices, Andy. And he's like rolling his eyes, like, oh my gosh, again, this guy. Right.
I'm just gonna mention real quick. Getting late, but I think the Notebook website has Zelda on it and shows those tilted images.
Really? Okay.
The Notebook website.
It's interesting. Yeah, like I remember like I seeing that image and they're like they didn't really have their artists do that work.
Scene, you can
All right. Because like at the very least, it seems like something you could automate. Like you have them, model it, and then like you just do a step where it like tilts the model or something. But I don't know. But I mean, again, it's not like they did it wrong. It's just maybe it was more effort than they needed to do. You know. Oh,
Anything that's 3D is completely vertical, and anything that's a 2D sprite is tilted at the camera angle. So in Pokemon Diamond and Pearl, they have anything that's because it's a mix of like 2D sprite art and like 3D. All the 3D ones are not tilted back; they're perfectly vertical. And then any of the 2D sprite art is tilted.
oh, actually, that's kind of another good use case for like when you're drawing billboarded stuff is kind of like the generic term for that, right? When you need to, like when you have a thousand of those things that you need to draw, you don't want to do every single one of them to like rotate it on the CPU and figure out what that angle is. You kind of just want to do that like in a shader or something to figure out like which direction to have it go in. And the easy way to do that is like if you have the camera matrix, the view matrix, like which directions are pointed in the directions that you need to expand something to billboard it. So yeah, in the shader you can just extract those values directly out of the matrix.
Perfect. Profile.
Any more?
Thank you, Scott. Great.
Well, based on the number of questions, it either went really well or really poorly. I don't know. Good.